Right, so this warm-up's going to go over what we covered yesterday, distance, midpoint, and the coordinate problems at the bottom. I'm going to work through the distance formula for the first one. So the square root of 1 minus a negative 4 becomes 1 plus 4, plus negative 4 minus 7, and I get 5 squared, plus negative 11 squared, 25 plus 121, which is the square root of 146. And then remember, you want to check to make sure that can be broken down. So I can use a factor tree. This would be 2 and 73. 73 is prime, not going anywhere. So I know that that's going to stay the way it is. So A, distance is the square root of 146. Questions on that one? All right, B is now your midpoint, right? So B would be negative 4 plus 1 over 2, and then 7 plus negative 4 over 2. And you get negative 3 halves and positive 3 halves. And you can leave your answer like that, or you can make it into a mixed number. That would be negative 1.5 and 1.5, or a decimal because it would be exact negative 1.5, 1.5. But you don't need to do that extra work. So if I was you, save it. Keep it as the improper fraction as long as it's simplified. Questions on that one? All right, so I pulled in a graph for 2. And then I plotted the points. What's the benefit of plotting the points for a question like this where you're trying to figure out if these points are isosceles? Is there a benefit to plotting the points ahead of time? Would you agree that there is? Yeah, why?
You can see it.
You could obviously, from this one, see that there are two sides that look like they're closer in length than the other side, right? So it rules out, it eliminates one distance problem for you. So I'm going to say that these two here are the ones that look like they're probably the same. So I'm just going to use, the first ones I'm going to use are negative 2 and 4 and 3 and 2. I'm going to do the distance formula there. So 3 minus a negative 2 becomes 5. And 2 minus a 4 becomes negative 2. And I get 25 plus 4 square root 29. And then I'm going to do 3, 2, and 1 negative 3. So 1 minus 3 is negative 2 squared, plus negative 3 minus 2 is negative 5 squared, 4 plus 25 square root 29. So because we're looking to prove that this is isosceles, all we have to do is show that the square root 29 equals the square root 29. If there were letters for those vertices, I would actually say like AB equals BC because square root 29 equals square root 29, but these don't even have letters. So as long as you've got the work to show that the distance is the same, that's all I need. If it was equilateral, we'd have to do all 3 pairs and show that they were all 3 the same. How many of you got both right on your first warm-up? That feels good, right? Okay. We're going to go over the homework that was due this morning. So the 2 PDF homeworks, and they'll be sporadically throughout the year, reviews and stuff, but these 2 that are not in your book, I'm going to go over the answers for, and then when we get to the online homework, which will start tomorrow, after the due date passes, you can actually go in and view the answers to your homework. So it will be on you to check your answers, and then also if you have questions, come in and let me know, okay? So 6 was the plotting of the points. 8 is negative 12, 0. 10 was quadrant 3. 12, quadrant 3 or quadrant 4. Yep.
For those questions, you have to put both, right?
Yes. 14, quadrant 1 or quadrant 3. 16, your scatter plot should have looked something like this. This scatter plot tells me I wouldn't live wherever this is because it's cold as heck. Yeah. Like if your peak is 30 something, no thank you. $18 was the square root of 289, which is 17. It's like one of the hardest ones to remember. $20 is a 20, something like 22, I would have let you use a calculator for because I don't expect you to know the square root of 296.2 off the top of your head. $24, the distance between those first set of points was 10, and then 3, and then the square root of 109. So we were showing that this is a right triangle. 10 squared plus 3 squared would equal 109. Questions so far? Okay, 26. The three sides were root 20, and root 40. If this had asked you to actually give those as an answer, like find the lengths of each side, then I would have expected to see them written as their simplified format, like 2 root 5, 2 root 5, and 4 root 10. I'm sorry, 2 root 10. Because you're just using it to verify this time, you can leave them as root 20, and root 40. But I'm pretty sure your quiz is going to say, find the length of each side, those should be simplified, and then use them to prove. 28, root 40, root 32. So you were showing that these two were the same. $30 was plotting of the points, finding the distance, which was 7, finding the midpoint, which is 9/2 and 4, or 4 1/2 and 4. $36, again, plotting of the points. B is square root of 82 over 3. And C, -1 7/6. 38. So if you didn't have a calculator, you would have left it as 2 root 505. Standardized test, because that's kind of where a question like this would pop up. You would then take it to the next step and say it's approximately 45 yards. 40, the midpoint would have been at year 2009, and the earnings per share would have been $2.36. And then 42, a shift right 6 and down 3 would result in 3, 3, 1, 0, 3, -3, and 5, 0. And a shift left 10 and down 6 results in -5, 2, -7, 0, and -3, 0. Questions on any of the homework? If you do have a question, maybe it's not today, but if you do have a question, I would prefer that you ask it in a setting like this so that probably someone else sitting in the same room has a question so they both get answered. But if you're uncomfortable with it, like feel free to send me an email that says, hey, can you go over this question in class? Or come see me before or after school, okay? Don't let questions go unanswered because you're too shy to ask in class, okay? Somebody in here has the same question as you most of the time. All right, R.2 is called Graphs of Equations. So this is the second and final section that's not in your book, okay? So the resources for this are the notes, the homework I'm going to give you tonight, the warm-up for tomorrow, and then I'll give you some practice problems on Monday before your quiz for Tuesday, okay? But R.2 being a review section, hopefully what we do today is a lot of review, okay? But if there's something on here that you're not feeling as comfortable with, again, make sure you speak up. So we start with just the basics of the points in the graph relating to an equation. If a point is on the graph of an equation, then when you plug that point, that x, y coordinate into the equation, the result should be a balanced equation. The left side should equal the right. So you would apply that in some way like this. Okay, determine if the given points are on the graph of the equation. So your graph or your equation is x squared plus xy plus y squared equals 4. And then your 2 points are 0, -2, and 1, -2. So this is like a two-part question. The first one is this point on that line? So you just take it and plug it in. Everywhere there's an x, I'm going to replace it with a 0. And everywhere there's a y, I'm going to replace it with a -2. And if I get a balanced equation, then I can say, yes, this point is on that graph or a solution to the equation. And then I plug in 1, -2. Make sure that when you're plugging in a negative, you keep it in the parentheses because there's a difference between this and negative 2 squared. Negative 2 squared like that is actually a negative 4, while the one that we're working with is a positive 4. Does 3 equal 4? No. So this is not a point that's on that graph, or not a solution to the equation. Can you have more than one yes? Is there more than one point on an equation?
Yes.
Yeah. You could have both yeses. You could have both no. There's no rule. Like everybody's like, oh, if one's yes, the other one has to be no. That's not a rule. Okay? They could both be no's. They could both be yeses. One could be a yes. One could be a no. Questions on that? So this goes back to like the basics of, like if you're ever on a standardized test and you have no idea what a graph looks like or what a point on that graph would look like, it's super easy. Just plug it in. Okay? If it works, then it means it's on that graph. All right, so we go back to the t-chart. So if you don't know what a graph looks like, which eventually when we get into transformations, you're going to get a little bit better at it, okay? Or we're going to review, and hopefully you'll be better at it. But for right now, let's say we've got this super funky graph. We have no idea what it looks like. Then you go back to the basics, which is plug in some points. So I don't care if your t-chart is vertical or horizontal. It's whatever your preference is. There's like two kinds of people in life. The vertical t-chart and the horizontal one. I don't care. They're both t's. Okay, they both work. If it didn't give you a set of points, I would say you want to plug in at least 3 and some sort of combination of negatives to positives. So -1, 0, 1 or -2, 0, 2, something like that. Plug them in, see what you get, plot your points. Connect your graph, which is something that not everybody does, which is interesting. I will get at least one quiz next week in which you plot your points, but you don't connect them. You have to connect those dots, okay? Sometimes they'll give you the points like this. So hopefully you can use some prior knowledge to figure out what this graph could look like. But if not, let's say it's not as simple as this, then you plug in some points. So I'm going to plug in each point into my equation. -3 times -1 plus 1, 3 plus 1, which is 4. And then go to the next one. -3 times 0 plus 1, 0 plus 1, which is 1. -3 times 1 plus 1, -3 plus 1, -2, -3 times 2 plus 1, -5. And then it wants the x, y combination in this chart, so I just write them together. -1 goes with 4, 0 goes with 1, 1 goes with -2, and 2 with -5. And then plot these points. Okay, hopefully our prior knowledge of equations could have told you that from the beginning this was a line, but they're not always going to be that simple. I always say, like, if example A is hard, it's going to be a bad day. Baby step our way into it. You guys do B. So once you plug in those points, you should have gotten -1, -1, 0, 0, 1, 3, and 2, 8. And then plot your points. It should look something like this. If I had given you this without a t-chart and asked you what kind of graph this would have been, what would you have told me? Sorry? More specifically, what kind of exponential? What happens if it's a squared? It's a parabola, right? What's wrong with my graph? There's no other side. Why is that happening? We just didn't go far enough back, right? So at this point, I mean, hopefully you know if it's a parabola, it's supposed to be a parabola. But if not, like if you get something that looks like x to the 5th and you have no idea what it's supposed to look like, don't stress about it. Plug in the points that they give you, okay? We'll have lots of time to get into, okay, knowing this is a quadratic. You'll spend lots of time with quadratic. This is a quadratic. I know how to find my vertices. I know how to find my intercepts and plot it to make sure you get that curve. But for right now, stick to the basics. Okay, if it gives you these points, plot those points. Again, make sure you connect them, and then don't stress about the fact that that didn't come up on the left side. If it didn't give you points, use your prior knowledge about what things look like I know that's a parabola, to plug in some points to kind of get a curve that would make sense. All right, intercepts. So there's two intercepts on a graph, the x-intercepts and the y-intercepts. There's two ways to find them. One is from the equation, and in that case, you'll plug 0 in for y to get the x-intercept. And plug 0 into x to get the y-intercept. And then if you have the graph, you just have to identify the point for the x-intercept where it crosses the where it crosses the x-axis point or points. And for the y-intercepts, it's the point or points where the graph crosses the y-axis. All right, so again, start easy, work your way up. So it says identify the x and y-intercepts, and A is giving me a graph, right? So if you zoom in on that graph, if I want to identify my x-intercepts, you would tell me they are where? 1 and 2, okay? I don't want you to write x-intercepts equals 1 and 2. I want you to write it in point format. So the x-intercept is when the y is 0, right? So it would be 1, 0, and 2, 0. Make sure you give me coordinate points. And the y-intercept is where? Good, 0, 2. Easy stuff, right? If it was a decimal, approximate it. If it looks like less than half or about half or bigger than half, just approximate it, okay? Second one is based on the equation, so we go through our process, right? So if I wanted to find, let's do y-intercept because that's usually easier. Let's do y-intercept first. So I'm going to plug in 0 for x. Y equals 2 times 0 to the third minus 4 times 0 to the second. This is 0 minus 0. This is 0. So my y-intercept is 0, 0. Oops. And then you've got your x-intercepts. So this time I set y as 0. Okay, and there's more than one way to start this. What is one way to start this? Good. Factor it out, okay? If I divide by 2, it's totally fine. If you divide by x, you actually lose information about this graph, so don't do it. Don't eliminate variables, okay? And then the easiest thing to do is factor 2x squared, and then I get x minus 2. And then property of zeros tells me that if either of those are zeros, obviously the whole thing becomes 0, which means I can split it and solve it. On the left-hand side, divide by 2, and I get 0 equals x squared, square root both sides. Even root property says plus and minus, but is there such a thing as plus or minus 0? No. So that's 1. Which is the one we already found.
So when you say you can factor a variable, you can if there's a number with it?
You can factor out a variable. You just don't want to divide both sides by x squared and eliminate it.
Okay.
Right now, it's not going to have a bearing on what happens right now with these, but I don't know if you remember, when you get to like higher exponents, when you have to like know if it bounces or crosses through a line. Do you remember that? Some of you might have learned that. Like if I have a graph that looks like this and I need to know if it's going to cross through that 0 or bounce off it, the only way to know that is how many roots you have. And if you eliminate zeros, you eliminate that. So for right now, it's not going to affect you, but I don't want you to get in the habit of doing it. So factor always, just don't divide by a variable to cancel it out. Does that make sense?
Yeah.
Okay. You're welcome. So then the other one is x equals 2. So 2, 0 is my other x-intercept. Questions on that one? Okay, and then it says graph B using a calculator to confirm. So I'm going to jump into the graphing calculator app if you've downloaded it, if you'll open it and follow me so I can show you how to use it. When it comes to homework and you're using to confirm, you can either use the app or you can use your handheld. That's totally up to you what you're comfortable with. So we graphed on the graphing calculator app, and then this is where you could confirm. So these points match with what we already found. So just to be really, really clear, if an instruction in your homework says to graph something and then answer questions based on it. So if it says graph this formula, find the intercepts, do this, whatever it is, then you need to make sure you're graphing it on either your handheld or your or your app, screenshotting it, or literally taking a picture of what your handheld looks like and bringing it into your homework. So if it says graph and then answer questions based on it, I should see your graph when you submit your homework. That's for two reasons. One, it lets me know you actually looked at a legit graph. Two, when we go over homework, if you didn't understand something and it's because your graph, we can't recreate what you did if you did it wrong. But we can, however, look at what you submitted, because then we'll know either was your graph wrong or did you read it wrong. If it's something like this where it just says use it to confirm, I don't need the graph. That's you checking your work. Does that make sense? So if you're using it to verify, you're using it to confirm, you don't need to take a picture, bring it in. But if it is saying graph this and then answer questions based on it, you need to include your graph in your submission. Is that clear? Yeah? Okay. All right, symmetry is something else you can find from an equation or from a graph. So if something is symmetric with respect to the x-axis, this means I can fold it top to bottom and it will overlap like a hamburger. If you're looking at the equation, then the way you find out is if you plug in a negative y, you're going to replace y with a negative y, and then simplify it. If it goes unchanged or every term is the exact opposite, because in that case I could just multiply everything by -1 and get it back to the original. So you just don't have to go through that extra step. So if it goes unchanged once you simplify it, or every single term is the exact opposite, then I can say that it's symmetric with respect to the x-axis. For the y-axis, you'll take x and replace it with a negative x, simplify it, and if it goes unchanged or every term is the exact opposite, then I would say it's symmetric with respect to the y-axis. And from a graph, we're folding left to right like a hot dog. And if it's symmetric with respect to the origin, then you would change both the x and the y to be their negative. So x becomes negative x, y becomes negative I. And then simplify it if it goes back to the original or goes unchanged, or every term is the exact opposite, then it's symmetric with respect to the origin. Graphs can be none of these, not symmetric to any of them. They can be just symmetric to the x, or just symmetric to the y, or just symmetric to the origin. They could be two of the three, or they could be all three. So there's no rule on what symmetry works, okay? All right, so let's look at the first one. Obviously, we have no idea what this graph looks like. I've got x to the fourth, y to the fourth, plus x to the second, y to the second, plus 1 equals 0. So my first test is to see if it's symmetric to the x-axis. What do I change if I'm doing the x? The y. So I go x to the fourth, plug in a negative y to the fourth, plus x to the second, plug in a negative y to the second, plus 1 equals 0. Make sure you keep them in parentheses because, again, those are two different things. So what happens if a negative variable is raised to or a negative number is raised to an even power? It goes back positive, right? So I get x to the fourth, y to the fourth, plus x to the second, y to the second, plus 1 equals 0. Does this equal this? Yes. So the answer here is that it is symmetric to the x-axis. What kind of exponent's going to leave a negative? An odd power. So if that was x to the third or y to the third, when we plug in, obviously it's not going to get rid of it. Then I would test for the y-axis symmetry. So this time I'm going to plug in a negative x. Negative x to the fourth, y to the fourth, plus negative x to the second, y to the second, plus 1 equals 0. And again, because they're even powers, I lose the negative. it goes back to the original. So it's also symmetric to the x or to the y-axis. And the last is the origin. And for this one, we change both. And we know because we just did it. Oops, I didn't do both. I said I did it and I didn't do it. So this is symmetric to all three, okay? If I fold it left, right, top, down, or along the y equals x line is how you figure out origin, then it would be all three. So think about what else would make it, because you don't have to go through the work all the time if you know what you're doing. What else is going to make a negative go away? What symbol in math makes a negative come back positive? Absolute value. So if it's raised to an even power, it's going back. If it's an absolute value by itself, it's going back. So like x plus 1 in absolute value doesn't work. But x by itself in absolute value is going to make it go back positive. Okay? Things like odd numbers or odd exponents are going to change your sign. So if you look at b, if I plug in a negative y, it's going to change the y, but not the x or the 1. So it doesn't work. If I plug in a negative x, it changes the x, but not the y, and not the 1, so it doesn't work. If I plug in both a negative x and a negative y, it's going to change those two terms, but still not the 1. So the only way that this would be symmetric is if you had some other, like if I had an x to the 5th here, that's going to be symmetric to the origin only, because it's going to change all three signs if you plug in both. Does that make sense? Okay. I'll work out that last example. So for B, if I want to see if it's symmetric to the x-axis, I'm going to plug in, actually I'll go in the same order. So x-axis, I'm going to plug in a negative y. And that odd power keeps that negative. So this time the x hasn't changed, the 1 isn't changed, but the y has changed. It does not match. So this would be a no in respect to the x-axis. So then I'll try the y. This time I'm changing the x. And again, it only changes one of it, not all of it. So this is also a no. And then we'll do the origin. Negative x and a negative y to the 3rd, which is going to simplify to negative y plus 1. So it's not the same as the original. Both this one and this one have changed, but this has not, which means that it's not symmetric to the origin either. So it can be just one, it can be two of these three, it can be all three, or it can be none like this case. The last thing in this section is circles. So the standard form of a circle is x minus h squared plus y minus k squared equals r squared. And from this formula, the center is hk, so whatever's here and here make up your center. And the radius is just r, which means whatever's numbers over here, we're going to square root to make the radius. So you're going to use this two ways. One, given a point and information about it, result in the actual equation, or using the equation to find information out about that circle. So in this one, it says find the equation of the circle. So our goal is to get to the point where we have the x minus h, where h is a number, squared, plus y minus k, where the k is a number, equals 1. Or sorry, equals the radius squared. So for A, the center is hk, so I just plug that in. X minus a negative 2 becomes x plus 2 squared, plus y minus k, k is 1, so y minus 1 squared, equals r squared, in this case would be 9. So notice that from the center to the equation, the signs are different, because in my initial standard form, it's minus. So minus a negative is going to go back positive, and minus a positive is going to stay negative. Second one says center is -1, 4, and solution point is 3, 4. So we again have the HK. This time, we're not given the radius. But if you think about a circle, if I have a circle and the center's here and there's a point on the circle, wherever it is around, the distance from that center to that point is going to be the radius. So you have two ways to find the radius. One is that, find the distance between the point and the center. So I would find the distance between these two, and that would be my r. Square root of 3 minus a -1 becomes 3 plus 1. 4 minus 4, and that's 4 squared. Square root of 16, which is 4. So I know the radius is 4. Then I could take that in the center and plug it in just like we did in A. Or I can use these 2 points, this as my HK, this as my X, Y, and plug it into the initial equation. So X, so X minus H squared plus Y minus K squared would equal R squared. So my X is 3, my H is a -1, 3 minus a -1 would become +1. Y is 4, K is 4, equals R squared. And then I would simplify this, so 4 squared plus 0 squared equals R squared. 16 equals R squared, which makes R either, technically it's plus or minus 4, but because we're talking about a distance, it's always going to be positive, so it's 4. So either way you work that out, you end up with the same set of information, which is that the center is -1, 4, and the radius is 4. Based on that, my equation would be X, so the center was -1, 4, and the radius is 4. Again, based on the information that was given to you over here and what we found from either of these places. So now I want to take that and plug it in. So I'd get X minus a -1, which becomes +1 squared, plus Y minus 4 squared equals radius squared, which is 16. And that's the equation of that circle. Okay, and then the last one, this time says endpoints of the diameter. So in this case, we don't have either the center or the radius. And again, there's multiple ways to do this. But if I have the endpoints of the diameter, so again, if you could visualize your circle, the endpoints of the diameter, and I want to find the center. Hopefully you remember that the diameter runs through the center. So the midpoint of the diameter is going to actually equal the center. And then once we are there, we have the center and endpoints, and you can do what we just did in B. Either find the distance from the center to the endpoint, either one, and that's your radius, or take the diameter, one of those endpoints, and the center and plug it in, and then you can find R. So let's start with the center. Because the center is the midpoint of the diameter, I'm going to do 0 plus 3 divided by 2, and 0 plus 4 divided by 2. So 3 halves and 4 over 2, which means 3 halves and 2 is the center of this circle. So then again, I can find either the distance from the center to the diameter, like we did in this first part, or we can take this point and either of those endpoints and plug it into the equation, or sorry, not that part. This part was the distance. Or we could take this as your HK and this as an XY, and I would definitely use the zeros because they're easier, and plug it in like we did here. So I'm going to work out that second one. So the X minus H squared plus Y minus K squared equals R squared. The X in this case is 0, 0, so it's 0 minus the H minus 3 halves squared plus the Y is still 0 minus the K, which is 2. Squared equals the radius squared. So this is -3 halves squared plus -2 squared equals the radius squared. 9/4 plus 4 equals the radius squared. Change these so they have the same denominators. This would be 16 over 4. This would be 25 over 4 equals the radius squared. So if I wanted to know the radius, I could square root that, and I'd get that the radius is 5/2. But I don't even need to do that because when I plug it back into the equation, it is squared. So now I need the center, which we said was here, x minus 3/2 squared plus y minus 2 squared equals the radius squared, which is 25/4. And there is the equation of a circle with the endpoints of 0, 0, and 3, 4. The good news is this last example is actually probably the easiest. Identify the center and the radius and then graph the equation. So from my actual equation, now we're working in reverse, I want to identify the center. Remember, it's x minus h. So this here, the 2 is h. And y minus k means I'm going to change the sign on this and say that -1 is the center. So center would be 2, -1. It's always the opposite of what's in the formula. And then this is the r squared, which means the radius is 2. So now I pulled in a graph here. I'm going to plot my center to -1. And then because my radius is 2, I'm going to go up, right, down, and left 2. So up 2, that's my 1 point, to the right 2, down 2, left 2, and then to the best of your ability, because they're not always going to look that pretty, you want to connect those points. Okay, and then B, center. There's nothing after the x and there's nothing after the y, so it's 0, 0. And the radius is the square root of 9/4, which is 3/2, or 1.5. Go to my circle, plot my center, and then I'm going to go to the right 1.5, up 1.5, left 1.5, and down 1.5. And there's your circle. And that's the end of the notes for R2. The assignment is on Canvas, and remember, we're going to do 1-1 tomorrow.